This lesson's title is Rules of Exponents. Our goal is to multiply and divide exponents. Let's start with multiplication. This is the product of powers property. To multiply powers of the same base, add their exponents. So this is what's going on. Let's say we have a squared times a cubed. We can multiply these two terms because they have the same base. This is what's going on behind this. We have 2a's here, and we have 3a's here. So altogether, there are 5a's. To get that answer, all you have to do, you don't have to expand it like we did here. All you have to do is add their exponents. So let's do another one, an example of which you will see in your homework. If you have the same base, this is the base, you can multiply. And to multiply, you would add exponents. So there are 18b's. This also works with numbers. Let's say we have 3 cubed times 3 to the 5th. Because they have the same base, they both have a 3, we can multiply, which means add their exponents. This works with with decimals as well. Here my base is 0.5. The parentheses on the left has an exponent of 1. When there isn't an exponent there, it's always a 1. So their bases would stay the same. And you would add their exponents. Okay, let's try a more challenging problem. Let's say we have 2m to the 4th times 7n to the 5th. This time my two terms have a coefficient and a variable. This is going to be taken in 2 steps. You're going to work with the coefficients out front. 2 times 7, this is not addition, this is a normal multiplication problem. 2 times 7 is 14. Now that I'm done with the coefficients, I can work with the variables. Because they have the same base, I can add their exponents. So my answer is 14n to the 9. I do want to show you an example when you cannot add exponents. Let's say we have x squared times y cubed. These bases are not the same, so you cannot add those exponents. You cannot do 2 plus 3. Your answer is just x squared y cubed. You can't go any further because the bases are not the same. Okay, let's try the next product property, or the next property. And that rule is the quotient of powers property. To divide powers of the same base, you subtract their exponents. So again, let me show you what's going on behind the scenes. Let's say we have a to the 4th divided by a. I'm going to expand this to show you what's going on. In the numerator, we have 4a's. In the denominator, I have 1a. We learned in the previous lesson that we would take the least common multiple out of here, which is an a. Sorry, greatest common factor, which is an a. And I'm left with 3a's in the numerator. Well, this product property says to divide with the same base, all you have to do is subtract the exponents. So 4 minus 1, we get the same answer, a cubed. Let's try another one. Let's say our base is 3 to the 8th and 3 to the 6th. To get our answer here, because we have the same base, all we have to do is subtract the exponents. So 8 minus 6 is 3 squared. And I'm going to leave it like that. I'm not going to expand it. 3 times 3, 9. I'm going to leave it 3 squared. So we have 0.6 to the 9th power over 0.6 to the 4th power. Again, we can subtract the exponents if we have the same base, which we do. So my base is going to stay the same, and I have 9 minus 4, which is 5. Notice that my answer is going in the numerator. Our answers do not go in the denominator because there is nothing else in the denominator. We took 4 away in the denominator, so we're left with 5 in the numerator. Let's try 12n to the 5th over 8n squared. Again, we're adding coefficients in front of our terms this time, so you're going to take this in 2 steps. I would work with the coefficients first. I'm looking at 12 over 8, so I'm thinking of it as a fraction that I need to simplify. The greatest common factor I see in there is 4, so I'm going to divide them both by 4. Okay, now I'm going to work with the variables. Because they're divided and they have the same base, I'm going to subtract their exponents. So 5 minus 2 is 3, and that goes in the numerator, because there are none left in the denominator. C to the 9 over 21c cubed. Same idea here. I'm going to work with the coefficients, and then I'm going to work with the variables. So let's start with the coefficients. 7 over 21 is a fraction which I can reduce, and I see that they have a 7 in common, so I'm going to divide a 7 out of both of them. I have 1 over 3. Now I'm going to work with the variables. They have the same base and they're divided, so I'm going to subtract them. 9 minus 3 is 6. The best answer here is c to the 6 over 3. You don't need the 1 out in front of the c. But I would accept this answer and I would accept this answer. Let's put these 2 rules together. You're going to see problems where they're going to have the product property and the quotient property in the same problem. So let's try 5x to the 4th times x to the 6th over 10x to the 5th. This kind of works like order of operations. I can't divide anything into my numerator is simplified, so I'm going to start in my numerator. And I'm going to start with the coefficients out in front, the 5 and the 1. So that's regular multiplication. 5 times 1 is 5. And then I'm going to work with the variables. They're being multiplied, so I add their exponents. 4 plus 6 is 10. The denominator stays the same right now. In the next step, I'm going to work with division. So again, work with the numbers and then work with the variables. I see I can pull the 5 out of the numerator and the denominator. So I get 1 over 2. The exponents are dividing. They have the same base, so I subtract. My best answer is x to the 5th over 2. I would like you to try one. Try x times 7x all over 10x to the 4th. Push pause and try that now. So let's simplify the numerator first. I have 1x times 7. 1 times 7 is 7. And here I have x to the 1st times x to the 1st. We add their exponents and we get x squared. The denominator stays the same right now. Now I'm going to work with the division. I'm looking at the fraction out front, and I don't see that they have anything in common, so it's going to stay 7/10. And I'm going to subtract their exponents. Do you see that we get a negative answer this time? We're going to learn more about this in the future. But there are actually more x's in the denominator. See how there are 2 left in the denominator if we take the 2 away from the numerator? So that exponent actually stays in the denominator. So I ended up writing this one wrong. I'm sorry. That's why you didn't know this rule. It should have been this. So we would have added, we would have gotten 5. This is something you know how to do. Here I have 5 minus 4, so I get 1. Okay, sorry about that. Let's try another one of those, see if I can write it right. 12y squared times 2y to the 8th all over 16y to the 5th. Push pause and try this one. Starting in the numerator, I'm going to multiply. And then my y's, because they have the same base, I can add. The denominator stays the same in this step. Now I'm looking to divide, so again, starting with the numbers, I'm looking at 24 and 16. Their greatest common factor is 4. Nope, 8. So I'm going to pull an 8 out of both of those. And then their variables have the same base, so I'm going to subtract. Now this is an improper fraction, just leave it improper. Don't turn it into a mixed number. 1 1/2 y5. You can just leave it. You're going to see a couple other things. For example, you might see this. X cubed times y squared times 3x squared. You're really just breaking it down into steps. Okay, I'm going to work with the coefficients first. It's multiplication. This is a 1, this is a 1, and this is a 3. So 1 times 1 is 1 times 3. Now I'm going to work with the x's. X cubed times x squared is x to the 5th. There are no other y's, so I just drop it down. Or maybe you'll see something like this. 14a cubed b to the 4th over 4ab. I see that this is a division problem. I'm going to take this in 3 steps. The coefficients, the a's, and then the b's. So 14 over 4, I see the greatest common factor is a 2. So I'm going to pull a 2 out. Now I'm going to work with the a's. They're dividing. They have the same base. So 3 minus 1 is 2. And then the b's. 4 minus 1 is 3.